Hi again. I would like to talk with you about delegated data preparation. So what even is data preparation, right? Initially, it didn't really have a name. You took a data, you put it in Lotus Node, and it would magically be able to be transferred to SPs, and SPs would compute, include this into the sector. But it turns out that people have a lot of data, and preparing that data is quite hard when you have terabytes, petabytes of data. So preparing the data can includes, like, for example, turning it into IPFS DAG, splitting it into separate deals that are sector-sized, computing the commitment over the data, and so on. So, and clients don't really want to do that because it's non-trivial. You need to have your own hardware, and also the trade-offs we chose, when we chose the methods that are required to confront for data preparation, so data that can be onboarded into a sector, there are trade-offs on both sides. Client has to do all this complexity, and Filecoin on the other side, for client's sake, accepts 300x cost increase for the data embedding proofs, because otherwise, it's completely not feasible for someone on end user device to compute 32 gigabyte commitment. That's nice in proofs. We use SHA for data in the ComD because it's nice for clients to compute. But it turns out most clients, especially larger clients, just offsource it, right? They moved it, they find someone who they trust and ask them to prepare the data for them instead of doing it themselves. From business perspective and from perspective client, it makes complete sense. Why would I have to bother preparing that data if I can just get someone else to do it for me? There are positives in that, onboarding data onto Filecoin becomes easier for clients, but also it creates a point of trust between client and data preparer. So it's non-trivial to enter this, right? Instead of it being when ecosystem around data preparation builds, at some point we'll have few parties who know what's going on and who are known, and then it will be harder to get into that. On the other hand, from protocol perspective and from Filecoin perspective, data preparer possesses more computational resources than the client. So we can see that something is shifting there, because previously, as part of data preparation, we considered, the client might be on mobile device, right? We cannot do anything computationally expensive for data preparation. So we saw, okay, clients started to delegate. So why not do it in a verifiable manner, right? We have a tons of provable computation that happens in Filecoin network. All the porets is essentially one huge provable computer about encoding sectors. This removes trust requirements for data preparers. Essentially, anyone could be, if data preparation was a provable computation, and anyone could be data preparer, same as anyone can be a storage provider, right? On the other hand, unfortunately, most data preparation transforms are not trivially provable. You just cannot produce a snark proof. You cannot produce a Suking proof that the computation was performed correctly. And let's give an example of a computation I'm talking about, which is the data preparation that happens today, right? Someone comes in, hey, I have SHA-256 hash of this 64 gigabyte blob. I want it on Filecoin. And now today, they have to compute the compy of that file, right? Ideally, they would be able to offsource that. Any questions so far? Okay. But the problem is a sequential SHA-256 hash is, you can create a snark to prove it, for example, but you cannot, it will use such amount of resources that it's infeasible. Fortunately, we have some networks that appear to solve this problem, right? We have Bacalhau, which aims to provide verifiability for arbitrary computation through replication, verifiability through replication, right? Essentially, you set up a game theoretic network where it doesn't make sense for you to lie to other people, to lie about the computation you've done, because you will be caught at some point that you're lying and you'll pay penalties. So at that point, if we have that, we have Bacalhau, which provides the computation. The client, the data preparer, becomes essentially someone who provides computational resources to Bacalhau, and there is, for example, a contract that allows you to use that. There are flows set up on Bacalhau or another computational network. Client computational capacities stop mattering because the client on the edge device can use Bacalhau, as can a client with a petabyte of data they want to onboard. And we end up with a very clear separation of client's format from the prepared data format, right? Because now the client doesn't care whatever format of whatever hash Filecoin uses, and Filecoin doesn't care about the hash that the client uses. Hash is the simple example. It could be format, it could be char versus flat file, and so on. So client's data is as flexible as Bacalhau can compute over, can fetch and compute over. And prepared data data format can adapt to the needs of Filecoin. So for example, few of those adaptations that either didn't happen or will be hard to do without something like this, without the clear separation, is initially the way we calculated the cost of Snapdeal's proof was 100x cheaper than it is today. But we forgot about one detail, the comd user SHA function. And the cost of Snapdeal's proof increased 100x because of that one decision that was made in the past, right? If we could change the commitment format for Snapdeals, for comd, Snapdeal's proof itself, the proving part, would be around 100x, like 60 to 100x cheaper. There are also new formats and commitments that are coming out for amazing capabilities of zero-knowledge improving systems and so on. Like, for example, polynomial commitments, where you can have semi-homomorphic properties over data, where you can triply prove it in proving systems, creating, like, for example, proving-friendly data structures. So you can imagine a distributed database that works in zero-knowledge that you can query over and prove that, oh, I queried some huge data set in zero-knowledge, and that this is the result I got from this query. But not much of this can happen unless we separate this boundary, because if client has to be able to compute the commitment of the data stored on Filecoin, we'll be stuck in this world where the trade-offs don't cause us to land in the middle, and the middle is somewhere where neither of us wants to be. Any questions?
Hello. So first question is that you mentioned that it's quite computation expensive to do the data preparation for data preparer. That means actually a lot of data preparer, they're investing a lot of hardware on that. So I wonder, one, what is the overhead of the Bacalhau? So if it actually needs more CPUs or needs more computation power to do it in a verifiable way, then that might not be very adaptable. And my second question is there any current working POC of this?
Of data preparation on Bacalhau? Not as far as I'm aware. So this is just an idea that evolved from the whole thread of commitment translations and so on. I wouldn't say, so Bacalhau at the end of the day is at least right now, it's a provable computation through replication. So worst case scenario, they are 2x more expensive for computation. With correct game theoretic approaches, they can get it very close to 1x, right? So yeah,
To be clear, the distributed network, Bacalhau, requires very, very little compute. This would be, there's no question there's incremental cost. The moment you're starting to do things like ZK and so on, you're going to add incremental, but it's not the network that's the cost there. It's the fact that you're choosing to do this additional verification. And exactly like Kuba just said, as we continue to expand over time and develop a network that allows for things like slashing and so on, you won't even require, like, it will be much more modest because the amount of verification you need to do on any given node will be continue to be reduced. Again, what we'd like is for folks to adapt whatever level they want as part of the spectrum. So if they're saying, hey, I want this to be ZK provable no matter what, then you're going to pay the maximum in computation, but that's their choice. If they're like, hey, you know what, I'm okay if this is, reduced in cost, slightly verifiable or consensus verification or things like that, then great. You can dial it all the way back and make it very modest.
My question is actually related with what David just said about the slashing mechanism. I'm wondering if you have thought about the incentive for being a data prepper and what kind of like this distribution. For example, it's like, okay, I'm a prepper and I'm actually cheating. So cheating on the data preparation so I can save some resources but still getting the money from the client. Who is going to dispute the data prepper?
So that's the role of Bacalhau network, right? That's their service they provide is offload delegated computation and security of it.
Exactly. So what will happen there, again, and it totally depends on what you would like. If you'd like it to be ZK provable, that's like one level. With slashing in particular, what the standard methodology would be to deploy it amongst a set of actors, untrusted actors, and you could achieve consensus verification where you could say, all right, within a window, for example, an epsilon, as long as all of these workloads agree, then, some majority of them agree, then anyone who doesn't agree will be slashed. And if you spread it randomly and things like that. And again, it very much, I would love to give you specific answers. If your workload is deterministic, you can do a lot more. If your workload is non-deterministic, then you'll need to spread it further. It really is up to you. But the network can be tuned in whatever way you want according to the job.
How painful would it be to change the SHA?
Change what?
So to like make it cheaper in the context of like because we choose like what was it, SHA?
Yeah.
How painful would it theoretically be to go through that? Like, what are all the things that we need to change?
It requires, so from network side, like pure protocol, Filecoin protocol consensus, not much. The majority of difficulty is the tooling and the client side. Because back when we implemented Snapdeals, over a weekend, I implemented an alternative version of Snapdeals that went through trusted setup. So we have a circuit for it. And it was also proposal, there was a FIP, I don't think it was a full FIP, it was a FIP discussion about cheaper Snapdeals, Poseidon Snapdeals, right? So it's possible to do it. The question is, how do we solve the client side, right? Which is what this whole presentation is about, is how do we solve the client side? In the cases where data preparer and the SP are the same person, I guess it's solved, but in the other cases, I'm not sure.
Okay, so it just requires a FIP.
Sorry, Jennifer, there's, I think, second mic there on the table. See it or not?
Can we simply like adding more versioning into our actors so that we can actually iterate on things like this?
So I'm not worried about consensus side, right? I'm worried about the whole ecosystem of tooling, of retrieval markets, of deal markets, and so on. Like the off-chain ecosystem of protocols that exist.
Totally. Like thinking of like FRCs and things like that. It's like adoption, comes along. So like if we can do versioning, people can, keep supporting the version 1 of Snapdeals and slowly adapt version 2 of like Snapdeal. Like if it's cheaper, more service providers doing that, I feel like ecosystem could evolve around that. I don't know, Fieldmind builds a lot of tooling.
Like you just flip it and someone is going to build it and they know who.
Riva.
Yeah, I want to add a thing here. So when you talk about cheaper, it's very important to remember who is it cheaper to. Because yes, Poseidon commitments would be great for SPs. They would suck for clients. So clients today will be able to run at about, I don't know,
The whole
10 megabytes per
point is,
second. But if we ship something which is cheaper for SPs, SPs will automatically snap onto them, get to do only that. And then we're going to very quickly end up in a network where nobody wants to do the cheap for SP thing, which is expensive for, the expensive for SP, cheap for client thing. You will not find anybody at any price to do that. So the moment you introduce something like this, if we don't have a very well thought through crypto econ almost, circuit for this, you have just made your network 100 times more expensive, and this is your new normal.
let me respond. If we're talking about just Poseidon Stadios, I agree. It's a risk. In cases where we build up this capability of clients being able to prepare offload their data preparation, right? At this point, client doesn't care what commitment SP is using. Because client should be convinced by the data preparation process that whatever data they had has been transformed and stored on a network right now under this other identifier. They don't have to explicitly verify this identifier, this CID, because they should be able to just go to their original CID or SHA or whatever to verify that they got the same data back. So client in the verifiable delegation scheme never has to compute, for example, the Poseidon commitment.
Yeah, isn't it the case today already? Like most of the clients don't actually do the data preparation anyways. No? They do?
All the clients that I work with are effectively required to do their own commitments, because this is the only way that we can show them that things actually end up on Filecoin. Because again, like this, and Kuba, correct me if I'm wrong, like this is a proof of concept. This doesn't exist today. So today, if you want to actually know that your data end up on Filecoin, you calculate the commitment yourself. There is no other choice.
Or you use someone you really trust, like you have essentially a full-on business relationship with, right? Same way you would have a business relationship with AWS or Barclays to do data preparation and storage for you.
Yeah, Riva has a point, because like we were having lunch with Andrew, who was also just telling us the ISVs why they really even consider Filecoin is like they're looking for using the blockchain perspective of it's like if their data is on Filecoin, they want to know there's a proof their data is on Filecoin. And on your next slide, basically they lose that traceability a little bit. I think a slide after, because now clients have a copy of their data, but data prepper can basically alternate with the different indexing on how they can actually reference the data on chain, and for the end client, we kind of have to, they kind of either keep their own indexing again, build additional toolings, otherwise they have to build this trusted relationship with prepper, which is additional tooling for the ecosystem.
I think it's a bit orthogonal. Like you could index it on chain, whatever way you like you can index by both commitments. Maybe the client wants 5 different commitments, wants to transform the data into 5 different commitments. And Bacalhau and the data, data preparation through a network, provable computation network would allow them to do that. So that's separate from storing the metadata, right? And if Bacalhau can provide strong guarantees that computation was performed correctly, then you don't always need cryptographic proof. And for some things, we cannot produce cryptographic proofs. And at that point, it's either client computes it itself, or we rely on optimistic computational networks like Bacalhau.
Do we have time for one more remark? No. Okay, so one more reminder about the COMD versus the entire proving circuits and so on and so forth, this only happens once for your data, right? You don't need to repeat the equivalency between a certain data commitment versus some replica for your posts and so on and so forth. So once you put it on the network, you're done. So the cost, while being high at an instant when effectively the POREP happens, it is not, it amortizes through time. Because if I keep this commitment for 5 years, it costs nothing.
Sure, but we're talking about alternatives where data can move across sectors, right? In that case, every time content of the sector changes, you're paying that cost. We're talking about cases where like data can outlive sectors. Again, the same situation. And in this case, the client doesn't really carry any cost as long as they, in the verifiable delegation, doesn't carry any exorbitant costs, right? As long as those services exist and they are providing some level of provability, client can rely on them, pay them to prepare the data, simplifying their workflow, and get the bonus of still being able to use their own identifiers. So let's say someone, oh, I have to keep on using SHA-2 because that's my whole company is doing that. I cannot switch to whatever you're using, right? They can still continue doing this. They just will have like a cross table probably of, oh, my SHA-2 here is in this deal or with this different data commitments, or maybe we allow them to store these additional their own identifiers, right, with the data, with the deal, whatever deal structure we create at that point. Any more questions? Otherwise, we can move on. All right. So next session is a workshop. So I would love to engage with you a ton. And the topic is a more flexible sealing pipeline. So things like non-interactive POREP, like reducing onboarding to just CC and SNAP, proof of access. So let's discuss. If someone wants to start with a question for any of these, go ahead.
Yeah, can you expand a bit more on proof of access?
Yeah, so proof of access essentially is a proof that you possess a way to access a piece of data. It doesn't come with a replication guarantees, but it says that I've accessed this piece of data. So the way we would use most likely proof of access here is to show that you possess data to facilitate fast retrieval, right? So you possess the unsealed copy of the data.
You possess ability to quickly access the clear data.
The cleared data?
Yes.
Unsealed. Unsealed.
Oh, I see, but I don't need to keep the copy.
Yes. So for example, what happens is without replication guarantees, you're permitted to amortize this cost. For example, you could create a cabal of storage providers who all share a single S3 bucket with all the data that requires fast retrieval and use this one single S3 bucket to show proof of access for all of these.
Sure. But yeah, like, can you expand on why that specifically happens when you have CC plus SNAP versus when you have like verifications that are still
So the reason is it's somewhat connected to CC plus SNAP is the same restrictions that land on proof of access, on SNAP deals where you cannot snap into sector that was already sealed with data. The same reasons apply to proof of access. Essentially, we are missing a piece of information that's created during sealing process to allow for a proof. And exposing this information directly today would require a new trusted setup, new circuit, and so on. We have some ideas how to create a path for us to enroll existing sectors after some point. We still won't have the proof, but we'll have a ability for them to create the proofs after the time. So we are looking at this. for cases of sectors with deal data embedded in them already without snap deals. Essentially, we're missing the commitment to to last layer to clear sector key without any data in it.
Cool.
So that's the same reason why we can't do currently you cannot do snaps into deal sectors. Like there exists also a world where we either change a proving system to something else than Graph16, or to something that has universal trusted setup at least, or we run a new trusted setup for Graph16, phase 2 trusted setup for Graph16 to get new proofs with new features that that enable those things, right? So we could have a non-interactive sector onboarding where it doesn't matter if you include the data at the point of sector onboarding, or if you not, you can still snap them into. And that also allows then proof of access. Yeah.
Could you expand a bit more on the non-interactive Power App and how it influences the sealing as a service?
Yeah. So for sealing as a service, right? The largest thing is it doesn't require pre-commit deposit anymore. But I think the question was how it works, right? Or
Essentially just a bit more information on how it works. Yeah.
So non-interactive Power App, the simplest implementation we could do right now without trusted setup, new trusted setup. Essentially, it requires you to produce 8 proofs instead of 1. And this gives us strong enough cryptographic guarantees to allow you to do the process non-interactively through Fiat-Shamir transform. So this would allow you to, essentially you generate the randomness locally instead of waiting for randomness beacon to give you randomness. You can generate randomness locally based on the outputs of the sealing process instead of having to use the randomness beacon. But the trade-off is, to allow you to do that, we have to improve our security margins, which requires 8x number of proofs. The reason we didn't do it initially is the proving process used to take like 3 hours. We are way down from that, right? So now 8x, increasing it, like we went down like I think more than 20x on proving speed, or even more. Then finally the 8x increase seems to be something that we can eat up and remove this, I would say, a small gremlin from the protocol, which is the PCD pre-commit interactive randomness. From security perspective, we never liked it, but it was a means towards the end of releasing something that can work.
Thank you.
Just for reference, we did start when we launched. It took about 2 hours and 40 minutes. Today it takes about 2 minutes and 40 seconds to do exactly the same work. So.
Really? Well. So yeah, so I don't know if and everyone, because I didn't prepare much slides for the session. So CC and Snap plus Snap idea is generally about moving everyone towards onboarding CC sectors and then including data into that. If we knew about this being a possibility back when we designed Filecoin, probably this would be the pathway we went through. But Snap Deals was something that was completely, something like Snap Deals is something that seemed completely unfeasible when we initially designed the protocol. It's quite a leap to understand everything to the degree where you can show that Snap Deals is secure, which was required for us to create something like that, right? Like at the time where Filecoin was created, and Filecoin proofs were created, like we were barely comfortable with the security margins that Filecoin proofs gave us, but we knew they had their limits, and we didn't want to push them. And over time, we became more confident, and we managed to design Snap Deals. So now the question is, should we move towards that pathway? And as Alex introduced in the intro talk, if we can bring down the cost difference between proof commit with deals and CC plus snap, if we can bring down this cost difference enough, then it might be a good move for the network to go into that direction.
Is this on? Hey, this might be sort of a noobish question.
Yeah.
I think sometimes distributed systems are best described when they're broken down into building blocks. And so I wanted to ask a question because I'm having trouble understanding this part. Would it be useful to have a building block where it's essentially imagine a Filecoin Lite. The goal of Filecoin Lite is to store no more than one copy of a particularly interesting sector. So let's say you have a sector, it's 32 gigabytes, and you don't ever care about storing more than one copy. You will always only store one copy or less. If we had that building block, then there are a lot of other interesting things that could be built on top of it. But I was reading the collection of reasons for why there's motivation for proof of replication. The three referenced in the original white paper are Sybil attacks, where malicious miners could pretend to store more copies than are physically stored.
So they could fake. So let me first respond to your initial question. The proof that there exists at least one copy of data somewhere is proof of access.
Sure. Okay.
So that's exactly what you're asking about. The major difference about proof of access and proof of replication, right, is that you want a unique replica that exists, and you want to be able to say, I want to have more than one replica.
Okay. So what I'm asking, I guess I'm observing a collection of problems, and I'm coming at this from a different history of design space. And so from an architectural design perspective, rethinking some of these core assumptions could be helpful getting out of a local optimum, right? And so the question that I have is, if it was to, let's say that you were to have a layer on top of this Filecoin Lite that I'm describing that does erasure coding with encryption. That would be a building block on its own that would guarantee that all of the pieces that were emitted from that higher layer would always be unique pieces. Every piece would be unique outside of a encrypted Reed-Solomon layer, right? Like if you put if you encrypt data with a unique key and then you Reed-Solomon encode it, every one of those pieces is unique.
How do you guarantee who chooses the key?
Well, the key could be generated based on the upload time and the DRAND output hashed together with some private key.
Sorry. How we get there, it doesn't really matter. What's the goal? Yeah.
So I guess what I'm saying is I think there's a collection of problems that could be solved here where if the goal was we don't actually care about Sybil attacks because we only want to store one or less pieces. We don't actually care about outsourcing attacks because there's only one or less pieces. And we don't actually care about generation attacks because the tokenomics of the network are such that it's not feasible to do so, and perhaps the power of the contribution to the mining pool was less. You don't need sealing.
So what you just did with this encryption and erasure coding layer is you attempted to create a proof of replication, essentially. And
I'm trying to break it apart. I'm trying. You of course want durability in your storage.
Yeah, exactly.
But some of this, I guess what I'm trying to understand is there's goals here to.
So the goal that your Filecoin Lite doesn't cover, right, is we want to prevent everything degrading into everyone going to every SP collecting together and storing everything in backplace, as an example, right? Or everyone going into one place, into one warehouse and storing,
Why would that happen?
Sorry?
Why would that happen?
Why would that happen?
Yeah.
Because essentially what I can do in case of this Filecoin Lite style proposal, Alex, is all the data stored is stored in one place. Even though you have erasure coded versions of it, they are not stored anywhere. And every time you someone asks you to show you their erasure coded version, I just go to this data warehouse, pull out my version, re-erasure code it, and show it to you, right?
You're saying that this is if the nodes are aware of the erasure coding, but if it's a separate layer, then that's not actually an attack. That if the client is what's doing the erasure coding, then the nodes don't necessarily know what pieces go together. This is all encrypted. It just looks like a building block that just does one or less piece storage. And if you have a building block that does one or less piece storage, you can layer another thing on top that is a separate trust model that generates unique pieces. And then those pieces can be stored in this layer without sealing.
I don't quite understand how the base layer that you proposed would be sort of useful on its own without the layers above it. Like, why would anyone build or use the base layer?
No, of course. You would only want it with the layers above it. That's true. But composed in this way, you would be able to do streaming, on-demand upload and download, right? There would be no need to unseal, and there would be no need to seal. There'd be no need for data preparation, and there'd be no need for data unpreparation. So I guess, yeah, what are we gaining by throwing that away?
The erasure coding, in your case, is the data preparation, right?
But that can be done streaming.
Sorry?
That can be done streaming. That can be done online.
One of the implicit design goals for something like Filecoin is that it is a sovereign blockchain network that is secured by its own layer. If you threw that desire away and just wanted it as proof of access protocol, you could build it on some other blockchain and do what you're doing.
That's not what I'm proposing. So I'm not proposing that Filecoin give up any of its sovereignty. I guess what I'm asking is, if Filecoin by itself was responsible for its own blockchain and for keeping track of these pieces, then another layer of end-user encryption could be layered on top to associate the pieces with their Reed-Solomon compositions. This seems like another problem. It seems like there's a lot of solution space diving in on trying to identify how to solve the making sealing fast problem.
Yeah, so one problem with that is you cannot build a consensus system based on that primitive.
Why not?
Because I can pretend to be a random client and onboard 10 petabytes of erasure coded data with myself.
It's true that the power fraction of a miner being tied to the amount of data stored would complicate the consensus protocol. But that's something where you could continue to store some data, the archival data. You want to have different tiers of data, right? So maybe some people are uploading data quickly and they want it staged. There could be an archival layer, and then only that archival layer contributes to the power fraction for managing the consensus layer, right? So I think it's possible to solve a proof of stake or a consensus layer like a consensus algorithm set of problems without requiring that all data be sealed.
Sure, you could think of the archival layer that you pointed out as Filecoin, and now we can build the second bit as a layer 2, as something else.
Okay, sure.
Which is something we talked also in the past of like different storage guarantees, right? Because proof of access is especially saying, oh, I don't care how many replicas I have. I care about there's at least one somewhere, right? So different tiers of guarantees is something that we've discussed in the past. Right now, we are providing like as strong guarantees as we can, allowing everyone else to rely on those strong guarantees to build their own protocols. Like it's easier to bootstrap an ecosystem from strong guarantees than weak guarantees and relying over everyone to build something, right?
I don't think that this is a weaker guarantee, though. And I guess what I'm proposing, just to be clear, so I work for Storage Labs. I'm not proposing something that Storage Labs does. Like this is not a design or a thing that exists in the world. I'm sort of interested in learning more about Filecoin, and what has stuck out to me is, wow, there's a lot of work that we need to do as a group to figure out how to improve sealing and make it so that we can access data. And so my first question was, well, why are we doing it? That's just where this is coming from. Is there a way to pursue maybe solving some of the other problems by just getting rid of sealing?
The thing that you don't get is a formal way of knowing that something is really replicate it somewhere. And if you don't get that, you're not able to have like incentives that allow people to be competitive with the cloud providers. You'll never be competitive with the cloud providers without like an incentive model that comes from the block rewards.
You can still do proof of storage, proof of space time on top of an object if you only care about storing it 1 or 0 times. So
Yeah,
proof
but
of space time
then
would
you
still
have
work.
the problem that we mentioned earlier where you have one copy of the data like once stored in one big warehouse and then a bunch of people pretending that they are storing the data.
And this is where we could potentially solve that problem by having 2 tiers of data, right? So like I just, it seems like there is a route here, I think, where Filecoin could dominate the world by having.
So you cannot have an incentive structure on the, like what Vuk said, like you cannot have incentive structure on the first layer. You cannot have the incentive structure on the second layer. So essentially what you said earlier is you have to have like even lower layer that provides the POREP guarantees for incentive structure to exist. Because you cannot have incentive structure on the first layer. Anyone can add as much data as they want to it. You cannot have incentive structure on the second layer because again, anyone can add as much data by themselves to it as they want, right?
Yeah.
Maybe a question, Kuba, just to give you the control as the speaker and track lead in this context. Like, I know we could talk probably a lot more about what is the purpose of proof of replication and like how it fits into Filecoin's proof of storage and block reward system, but I just want to double check that that's the conversation and the design space that we're aiming to pursue in this workshop, because I know we have a lot of other things. Like I have notes from the talk that Banyan just gave on the 5th floor about the challenges that they're having around like being able to delete data. And I know that was something that came up when we were talking about having snap deal sectors and being able to like re-snap a sector to provably show that you have changed the content within that area. And I just want to double check that you're driving the schedule as you desire.
Yeah. We can discuss later in corridors. But yeah, the deletion question, the deletion problem itself is an interesting one because like on one side, there's nothing preventing us from doing re-snap today. Like we could probably have a code ready for it in a week. At least from protocol side, I don't know Lotus and partners, but from protocol side, sorry, I still forget that protocol isn't everything. But yeah, like re-snap for deletion, it's a solution. I agree. Like it's a solution that people want and that we'll have to provide. On the other hand, it's a solution that doesn't like it's almost vanity. Deletion is a vanity from my perspective, especially in the distributed networks. I know you're shaking your head, but
I'm just coming from the set of people upstairs who are talking about paying lots of money for PIBs of data storage, and one of the enterprise compliance things they need is to demonstrate that data's been deleted.
Yeah.
And so right now what they're doing is they're paying storage providers and running an additional node next to their Boost node and their Lotus node that will monitor that they don't offer retrieval for any data in that sector after it's been deleted by the client, right?
Yep.
So they are doing weird ass whack-a-mole on top of the existing protocol in order to meet the user need, which is I've asked for this data to be deleted, and you as an entity who's offering enterprise grade storage on top of Filecoin are telling me it's happened. So this is what they're doing right now.
Yeah.
And so the question is, could we give them better protocol hooks that they could utilize that would be lower cost and like viable? Because I do think there's the flip side of, I believe for re-snap to be a viable solution for the deletion needs, they would need to have snapped the sectors to begin with, at least right now. And obviously they haven't because most people aren't doing snap deals. And so we have like an incentive cycle that we would need to, A, make sure that almost all data was being onboarded via snap deals, and then B, enable re-snap, C, be able to have like auditability, or like re-snap would need to be a thing on chain that they could monitor, which I think it already is. So that, and they would probably in this context, sorry, I'm just running back and forth from the previous one. In this context, they would probably be the one doing the re-snap into the sector, but then they were curious, could they, as the original creator of the deal, like modify the deal terms or I don't know, find some way to avoid slashing that storage provider if they've re-snapped in some way. Anyways, there's an interesting question there that hits the incentive side of things that makes it viable for the storage provider to take a re-snap over top of a deal. Actually, no, you could modify the deal's length, right? You could change the deal length to like be sooner, hypothetically as a client maybe, and then they could drop the deal and take a re-snap one. Anyways.
Yeah, so 100%, like in this case, it's something that a bunch of users, especially large users, especially users working with sensitive data, they want that possibility, and this is something that we'll have to deliver to them. I don't think, like right now, you cannot shorten the duration. And snap deals, if resnap were to be implemented, it would allow you only to snap over the data that was expired already, right? So you cannot do deletion at will. We could allow clients to terminate their deals at some point, but it would have to be both sides agree, I guess, because if the client is allowed to terminate a deal with SP, right? Especially in case of, deals onboarded with sectors instead of snap deals, then if the client was able to cancel the deal, if there was a payment in deal terms, then the SP would just lose out on the payments and the client still have their data stored. So it's a complex problem of how to do one deal cancellation to enabling the resnap or something like that with data onboarding sectors is another thing. One second. It's another thing on my bucket list of things I would do if we could do another trusted setup or different proving system. And this list keeps growing and growing. So I think that's like at some point we have to bite the bullet. And the question is, how long will we wait out missing on those features? Because individually they don't seem large enough. But yeah, I started making a list, and there's a lot there that depends on another trusted setup, another circuit.
If I remember correctly, you also mentioned once that one of the ways to achieve an IPO wrap was actually do another trusted setup, which can enable us to do resnap in the sectors, right? Like without the trusted setup, that cannot be achieved.
Without another trusted setup, we cannot do snap deals over deal sectors. I mean, in theory, we cannot. We just cannot. Let's say that. We either have to implement different proof, or we have to do another trusted setup to be able to snap into deal sectors.
And so, Jennifer, that is, you could resnap over a snapped sector, but you couldn't resnap over a sector that was onboarded with deals. Correct, Kuba?
Yes. Although, yes.
Well, if you start storing the proof of access style stuff, then you can, because you have a compliance on.
So the same thing is true about proof of access. It all depends on the same commitment that we are missing today, commitment to clear replica, and it's the same commitment that enables proof of access, the same commitment that enables resnap over CC, and because accidentally or because data is zeros, when CC sector gets onboarded, the commitment that we need for all this operation gets exposed as final sector commitment instead of, So that's the reason snap deals works at all. So we need, but for non-interactive forward, there are techniques that we discovered during snap deals where we can slightly, I don't want to say significantly, but slightly optimize structure of circuits, repeating circuits, especially in graph, that would result in I think on the order of maybe 10% reduction in circuit cost, which would be useful for non-interactive power rep if we, because the circuit grows 8x, right? So there are a bunch of improvements there that depend on circuits. And we are in this limbo of, do we do another trusted setup with graph? Will something good appear? How do we transition and so on? Yeah.
Is it the sort of thing, I mean, interesting question of can we, I heard you're keeping a list. Can we literally aggregate all of those into the exact same? I mean, obviously, if we're going to do a trusted setup, maybe we just migrate to a system that's not going to require additional trusted setups, either Testudo or Halo 2 or something similar.
Yeah, exactly. Like whatever we do, I would argue that we, like there is an argument for sticking with graph for now. Essentially, moving on from graph requires us to create two distinct classes of sectors that are not compatible with each other, and create some difficulties around data commitments as well that we could today use, because most proving systems that possess at least universal trust setup would require different padding scheme for data. So there are complications around moving and moving to something with universal trust setup. But there are complications with staying with what we have right now because we require trusted setups. And since since launch of the network, we could done one trusted setup, right? Which was Snapdeals. And that was a month-and-a-half process of 2 people working on it. So yeah.
I just wanted to step back out for the deletion question. Everything that Kuba talked about is being able to prove a negative, that the thing that a particular storage provider is advertising as 32 gigabytes of sectors does not have a single piece in it anymore. This, we have to be very clear when we talk to clients that this does not guarantee in any way that the storage provider did not store this somewhere else.
Yeah, that's it's impossible to prove deletion, right?
Right. But that's exactly my point. So we should be careful how much work we spend on proving negatives on chain when we cannot prove them off chain anyway.
Sure.
Instead of working, for example, on a better setup and stuff like that.
But the deletion is just one of the use cases that something like generic resnap over all sectors enables, right? It's not that we want to implement resnap, we'll just implement deletion and nothing else. But it's a use case, and while the proving deletion, proving that you didn't retain data is impossible. You would still want someone, if someone had a compromising picture of you, you would still want them to see them deleted from your phone, even though they might have a backup. You would still want that. It's the same for those clients.
Right. It's really proof of replacement is what we're proving, that we took this segment and we replaced it with something else.
Yeah.
Yeah, but if the data set is big enough, you're kind of fine with that, like, because it's not really rational for you to keep like 10 petabytes just to like.
There are a lot of players who will gladly take your 10 petabytes with Fill Plus on them and will totally store it for you. So
Yeah, not if it's encrypted data that is hard to read, like in chunks and so on. By the way, I just want to remind everyone that like snaps are still like 0.001% of the network. So like this is all cool, but yes.
So,
Actually, like the issue is that at some point, like we didn't manage the narrative, and like SPs thought that CC was not profitable anymore, and snapping was not a thing, and just got out of control. Like.
So the reason why Snapdeals are not really used right now is there are additional costs, right? Additional costs to onboard storage. On one side, it's because the proof of Snapdeals is non-interactive, and the proof of PowerApp is interactive essentially, right? It's chain interactive. So it means that if both proofs were non-interactive, the difference would be 8x between them, not one-to-one as it is right now. There's also the aspect of chain costs, gas costs, which are significant for Snapdeals due to partially it's just additional operation that happens on chain. Partially it's the activation schemes that are getting fixed with either in DDO or whatever way we can figure out to fix them. Sorry.
Yeah.
I saw, I don't know if that was the idea for Web3Mine, from Web3Mine or someone else, the idea of bundling Snapdeals with CC onboarding, bundling that proof. it would save on a bit of a gas costs, but probably the proving overhead is the same. And I don't know if it would save that much on verification costs. Think for a second. Like it would save a bit on the gas, right? But like, is the gas there the deal breaker, or is it the additional proving, 2x proving that you have to do for snap deals?
Yeah, I also want to like emphasize like that this is context that we have, and probably like this room is like the best on the planet to understand this. Most SPs have no clue. So like SPs are gonna do what they think it's rational, not what is rational. And also there is a lot of cost that it's hard for us to take into account, like how much does it cost to have like your SSDs and like hardware that can seal, not seal. That's not cost that is taken into account here. And most of the SPs do that today because like they're assuming that they need to have the data there to actually be able to do verified deals. And then there is like a big coordination issue where they're not able to do anything and they're just basically seeing idle.
One thing that was only very briefly talked about in Singapore, but we didn't actually have time to work on, and it's day one, so we maybe have time to work on it here, in terms of like actually discussing how it might happen, is replacing deal sector onboarding with a concatenation of sealing a CC sector and then snapping the data into it. So if you choose to do both at the same time, you can. You will incur the exact same gas and computational costs as if you did these two operations separately. And so there is then no reason, like it is, we are kind of unoptimizing a thing that has been optimized, but then complicates the protocol, complicates the onboarding flow for storage providers because they're trying to take advantage of this baked-in optimization because we only added snapping later. And so by, say, unoptimizing that part, I think we might actually free up better client experience, better storage provider experience, because then they can resnap and utilize all of the snap processes that exist. And they can have a much, like, they don't have to worry about getting the data into their sealing flow and operation in real time. These two steps can happen separately on separate pieces of hardware that are provisioned and scheduled differently. And so I don't know, I'm curious about that, and if folks are interested in workshopping. I don't know.
Yeah.
Jennifer looks concerned. So if Jennifer's concerned, I'm concerned. But
I actually have a related question. I hold Mike for the past 20 minutes already. So like there's a lot of talk in the Singapore to talk about, hey, maybe we should just have one sealing pipeline in the Filecoin protocol. Don't give storage provider options. I will be interested in a deeper. We only have 3 minutes left, so maybe later time. But I will be interested in listing all the pros and cons to actually doing so. That would be something I would be interested in, like road mapping out. I will also be wondering, in your mind, right now we have a lot of options, right? Like ProRep, since that ProRep is coming, CC and Snap, ResNap, and also, so like what's the, like, where do you see the sealing pipeline to be the most optimistic in 2024? Like what should we be working on in 2024? That's one thing I really want to discuss with you deeper, if we have time. And also, I think one actionable item we could have maybe is to start writing down what kind of the feature that we're foreseeing here, for example, proof of deletion, POA, ResNap, that require a sector to be snapped in the first place. I feel like if we list out of all these future opportunities that snap sectors can bring to storage providers, and also optimize the snap deal cost, maybe more people will be actually working on CC plus snap. I feel like that is one thing we can actually start working on.
So
direct data onboarding.
So
I'm working on that.
So Molly, just to coming back to the, I will respond to Jennifer in a second. Coming back to the just do CC plus snap always. I think that might be a viable option, especially for non-interactive ProRep. Because otherwise the cost balance doesn't really make sense because essentially you're doubling the cost of proof, right? But in case of non-interactive ProRep, you're going from 8x cost of versus interactive ProRep to 9x cost. So like the difference is 12% of cost, which doesn't make it such a deal breaker, at least for non-interactive ProRep. And especially that using snap deals during interactive Power App onboarding would be huge waste, because snap deals is non-interactive. Like snap deals could be 8x cheaper if it was interactive, right? So yeah.
Yeah,
Sorry, the last part wasn't that important, but yeah, like essentially, if snap deals right today cost the same amount of compute that the Power App Proof does, or ideally it should cost similar amount of compute. If someone spent a ton of time optimizing Power App, it will cost less, but it costs similar amount of compute. Non-interactive Power App requires you to increase the compute of the proof for Power App 8x. At which point, adding the 1x of snap deals doesn't seem that bad of a deal, right? You go from 8x to 9x. But you unlock
Also with, louder. With non-interactive Power App, you would also make, like, the structure of non-interactive Power App would probably optimize best with sealing as a service and sealing providers. And you're not going to want to ship all of your data to the sealing provider and then back, like it just complicates the hell out of things. And from a timing perspective as well, this would want to probably turn out as many pre-sealed sectors using non-interactive Power App as possible and then load them onto the network. And so the data flow overhead of combining non-interactive Power App with deal sectors is also a pain in the ass that like maybe we should avoid preemptively. And just to make sure I'm understanding it correctly, that would look like effectively doing a non-interactive Power App only for CC sectors and then being able to snap on top of it with non-interactive Power App and not for deal sectors, and that would solve the problem.
Within the same operation, because otherwise you incur like activation costs and so on, right? Like if you were required to activate a sector and then you can snap into it, then you essentially repeat in the same operation twice. And as we are discovering, gas for bookkeeping matters a lot in the network. We'll talk about it tomorrow, but yeah. Anyone else? Vuk, you had something? Anka?
Yeah, I would like to hear more about...
Turn or not?
Now? Can you hear me? Yeah. So I would have liked to hear more about this polynomial commitment idea and where, like, the changing SHA and
so that's in reference of the previous talk, right?
Mm-hmm, yes.
So it's more of it enables us to use something like this, right? Because every time we discussed polynomial commitments for sector commitment, for sector commitments, we had some ideas. Okay, we can do this, we can do that. We are just waiting on ability to change them, to even consider changing sector commitments. But for deal data, we never even considered polynomial commitments because of their computational cost. But for some kinds of data, polynomial commitments might turn out to be the best kind of commitments, especially if someone wants to do, as I said, like, for example, provable computation over that data or something like that. ZK knowledge provable computation over that data. There's no better commitment than polynomial commitment for that kind of data due to the cost of access, right? So in that word, it might be worth to have so essentially, it becomes worth to have a variant of snap deals that supports a polynomial commitment. And by separating CC from data, right, then we don't really have to have a circuit for every combination of proof of replication and sector content, because we can essentially mix and match both of them, like whatever we want. On the other hand, it might turn out, like with universal trusted setup, there's quite low cost of having more circuits, right? Like essentially your circuits will become composable with each other cheaply because you don't have to run trusted setup.
Aren't the improvements to the proof generation applying to the polynomial commitments as well?
I'm not sure. I would have to ask around. Probably at least a bit, because like you cannot get 10x just optimizing like circuit structure, like just optimizing reading of the circuit, right? So they had to optimize the multi-exponentiation and field operations, field and group operations somewhere to get 10x, around 10x, right? So we should look into that. further because, yeah, as you highlighted, that will be applicable to polynomial commitments. Although all of that will be over BLS 381, which is for polynomial commitments is, I think, not optimal. Thank you, everyone. And if you have any more questions, the corridor track continues in the corridor.